The maximum wire size for a service entrance cable is not solely determined by the size of the service entrance. Instead, it's governed by the ampacity of the cable itself. Ampacity refers to the maximum amount of electrical current a cable can safely conduct without overheating and potentially causing damage or fire. Several factors influence a cable's ampacity. Firstly, the size of the conductors within the cable is crucial. Larger conductors have a greater cross-sectional area, allowing them to carry more current with less resistance and heat generation. Secondly, the type of insulation used on the conductors plays a significant role. Different insulation materials have varying temperature ratings, indicating how much heat they can withstand before degrading. High temperature rated insulation allows for higher ampacity. Thirdly, the number of conductors bundled together in the cable affects ampacity. When multiple current-carrying conductors are grouped, the heat generated by each conductor can raise the overall temperature of the cable. This necessitates a reduction in the ampacity of each conductor to prevent overheating. The National Electrical Code, or NEC, provides tables and guidelines for determining the appropriate ampacity of cables based on these factors. These tables take into account the conductor size, insulation type, and the number of conductors in a raceway or cable. For example, NEC Table 310.16 details ampacities of insulated conductors rated up to 600 volts, and it is not more than 3 current-carrying conductors in a raceway or cable or earth. Ampacity correction factors and adjustment factors are crucial for ensuring safety and compliance. Correction factors are applied when the ambient temperature around the cable is higher than the temperature used in the NEC tables, which is typically 30 degrees Celsius or 86 degrees Fahrenheit. Higher ambient temperatures reduce the cable's ability to dissipate heat, necessitating a reduction in ampacity. Adjustment factors are applied when there are more than 3 current-carrying conductors in a raceway or cable. These factors account for the increased heat generated by the bundled conductors. Ignoring these correction and adjustment factors can lead to dangerous overheating of the cable, potentially causing insulation damage, equipment failure, or even fire. When selecting a service entrance cable, it is essential to consider the overall electrical load it will be carrying. This involves calculating the total current demand of all the appliances, lighting, and other electrical equipment that will be connected to the service. The cable's ampacity must be sufficient to handle this load continuously without exceeding its safe operating temperature. Overloading a cable can cause it to overheat and potentially fail, leading to power outages or even fires. Furthermore, local electrical codes and regulations may impose additional requirements for service entrance cable sizing and installation. It is crucial to consult with a qualified electrician to ensure that the chosen cable meets all applicable codes and standards. Proper installation techniques are also vital for ensuring the safe and reliable operation of the service entrance cable. This includes using the correct connectors and terminations, providing adequate support for the cable, and protecting it from physical damage. Incorrect installation can compromise the cable's integrity and increase the risk of electrical hazards. In summary, the maximum wire size for a service entrance cable is determined by its ampacity, which is influenced by conductor size, insulation type, and the number of conductors. Consulting NEC tables, applying correction and adjustment factors, and considering the overall electrical load are essential steps in selecting the appropriate cable. Proper installation and compliance with local codes are also crucial for ensuring safety and reliability.